Take a look at these pictures. Can you identify the metal used in these objects? You're right, they are made up of the metal aluminium. Did you know that a type of chemical reaction is involved in the manufacturing of aluminium? It is extracted from aluminium oxide through a process that involves passage of electric current. Take a look at the chemical equation. You see that reactant has decomposed into two substances. Let us perform an activity to observe the reaction when ferrous sulfate is heated. Take about 2 grams of solid sample of ferrous sulfate in a clean and dry test tube and note its color. What do you observe? The crystals are light green in color. What do you infer? The color of ferrous sulfate is light green. Heat ferrous sulfate in a test tube or the flame of a burner. What do you observe now? Colorless gas is formed and a brown-yellow solid is left in the test tube. What can you infer? Ferrous sulfate decomposes on heating. Test the smell of gas liberated. This is an irritating smell like sulfur. Let us test the presence of sulfur. What can you infer? The gases are oxides of sulfur. Bring a strip of filter paper soaked with an acidified solution of potassium dichromate about the test tube. What do you observe? The orange color turns green. What do you infer? Sulfur dioxide reduces acidified potassium dichromate to chromium sulfate. Let us write the equation for the reaction when ferrous sulfate is heated. Ferrous sulfate crystals lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is a solid while SO2 and SO3 are gases. The reactant has decomposed into 3 substances. Also, observe the reaction with an acidified solution of potassium dichromate for testing presence of sulfur. More examples of such reactions. Heating of lead nitrate powder. Take about 2 grams lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame as shown. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, NO2. This is the reaction of lead nitrate decomposing into lead oxide, nitrogen and oxygen. Let us perform another activity. Take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take the test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Gas is collected in the test tubes. This is electrolysis of water. The reactant water has decomposed into 2 substances, hydrogen and oxygen. Here is another reaction. Silver chloride exposed to sunlight. Take about 2 grams silver chloride in a china dish. Place this china dish in sunlight for some time. Observe the color of the silver chloride after some time. The reactant has decomposed into 2 substances. You will see that white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. What is common about these chemical reactions? Such reactions where a single reactant breaks down to give simpler products are called decomposition reaction. We observed that light or sunlight was required for some of the chemical reactions to occur. Here are a few examples. The most important of all reactions on which entire living world is dependent is photosynthesis, which cannot occur without light. Similarly, in black and white photography, silver bromide film, when exposed to sunlight, decomposes to silver and bromine. These kind of reactions which cannot occur without light are called photochemical reactions. Take a look at this. Add a few drops of water on a wooden slab. Take a few grams of barium hydroxide in a beaker and place the beaker on the slab. Try to lift the beaker. Add a few grams of ammonium chloride and mix with the help of a glass rod. Now, try to lift the beaker once again. What do you observe? There was so much heat absorbed, the beaker turned so cold that the water below turned to ice. These are some of the reactions where heat is absorbed or require energy, either in the form of heat, light, or electricity for breaking down the reactants. Such reactions in which energy is absorbed are known as endothermic reactions. Are you now ready to compare endothermic and exothermic reactions? Check your answers against the table provided here.